All right, it's a tough question, and they want me to solve for x. A typical equation, right? They go on to say x is some positive real number, and then that's the equation I need to solve, and that's trouble for me. And I'll tell you why it's trouble. It's a nested problem. There's a nested floor function, and I gotta look at one thing at a time. The first thing I'll look at is the kind of peel it away, is that the floor of x, right, has got to be some integer, and since x is a positive number, I know the integer. I'm going to call it n now. Has to be a positive integer. I know that much. Now, certainly, if that's true, if there is such an n that satisfies this, what do I get over here? I get x, whatever the x is, some real number, has to be between n and n plus one. But it can't touch n plus one, by the way, because then the floor of that would be above the n. All right. So I think that's sort of satisfactory. All right. So what I want to do is I'm going to keep rewriting this thing and try to remove symbol by symbol. The next thing up, I got this over here, but I realize, that x times what? Well, the floor of x, and the floor of x I'll just say is n, and that equals 10. Now I got another thing I could remove here, and what do I mean by remove that floor symbol? And I would have, I'm not going to write it as x, and I'm going to write it as nx now. Has to be, well, let's see, it's an integer because the floor of it between 10 and 11, but I can't touch the 11, by the way. All right. So I'm going to take this thing over here and divide both sides by n. And what makes that really easy to deal with is that the n is a positive integer, so I don't have to worry about the directions of this thing changing. So what would you get? You'd get 10 over n x. I'm dividing by n, and that's 11 over n. All right. I'm going to claim that these two guys over here, they're really important to me. I have bounds on the x over here. So when I kind of look at it and realize that I'm really kind of wondering what the n would be. And the way I'm going to do that is look at the extremes. All right, so I'm going to say, and again, it's really the same thing, like you got the x here, you got the x there. So I'm going to say n would have to be comparable to that number as well. Let me write that down for you. So n, whoops, sorry about that. So the n would have to be less than or equal to 11 over n. So I'm looking at the extremes. Now I want to look at another extreme. I'm going to look at these guys over here. And let me write that down for you. And what would you get over there? Well, you would get 10 over n. Again, n is an integer. It's a positive integer. Would have to be this over here. Again, I'm looking at those extremes. So I boil it down to, kind of two things that maybe I could figure out what the n is now. All right, but I have to solve two inequalities now. And they're inequalities in one unknown. So again, what makes this easier for me to deal with is that n is a positive integer. Right, so I don't have to worry about the directions of these inequalities changing. So I can freely multiply both sides by n, and what would you get? Let's write this down. You would get n squared is less than or equal to 11. All right? So again, n is an integer, and I think to myself, I could probably figure that out, right? Certainly 1 would satisfy it, because 1 squared is less than, and 1's a positive integer, by the way, less than 11. 2 would satisfy it, because 2 squared is 4. 3 would satisfy it, but once I get to 4, it doesn't satisfy it, so I got to close it out there, right? I have to close that at 3. So there's only 3 choices for this. N could be 1, n could be 2, n could be 3, n could be, that's it, 1, 2, or 3. Let's look at this guy over here. Again, what's nice about this is I can multiply both sides by n. And what do you get? 10. Not going to change the direction of that inequality. N squared plus n. It's quadratic, by the way, but again, integers. So what do I get over here? Let's write this down. It's going to be 0. I'm going to subtract 10 from both sides. N squared plus n minus 10. Well, you know what? I'm going to start writing down numbers I think might satisfy this. 1 doesn't, because 1 plus 1 minus 10 is a negative number. Let's take a look at 2. Does 2 work? And again, I'm only looking at the positive integers. 2. That would be 4 plus 2 is 6 minus 10 is negative. That's not work. Let's look at 3. That would, well, 3 works. Right? So what do you get? 3 squared is 9. 9 plus 3 is 12. 12 minus 10 is definitely positive. 4 would work. 5 would work. 6 would work. Yada, yada, yada. Boy, that's a long list of numbers. But here's the deal. there's only one number that both of these inequalities share, and they both must share that, right? So what's the n going to be? N must be 3. Must be 3. So what do I have over here? I've got an answer to my problem, all right? Now let me write that down for you. I'm kind of ready to write that down. And let me write it down. I'll write it over here. So what do I have over here? And again, these two, the only n that satisfied them both that we looked at was 3. Let's write this down. So you got 3. So x has to be greater than or equal to 3, and it has to be less than 4. All right, and I got this over here, 10 thirds. Oh, wow, look at that, up to 11 thirds. All right, I'm a little confused right now. So what I want to do is, both of these have to be true. Both have to be true. So what I want to do is I want to talk about, I'm looking, if they're both true, they both have to share something. So I'm looking for their intersection. So I'm going to put the number 3 down first. I'm going to put the number 4 down. I'm going to shade into 3. And I'm going to go all the way up to 4. So I did that. Now right next to it, I'm going to put another number line down. And I'm going to put these numbers down over here. And 10 thirds is 3 1/3. It's over here. That's 10 thirds. And 11 thirds is going to be what? That goes in, let's see, 3, that would be 3 2/3. That's over here somewhere. All right, where do those two sets intersect? Here. That's the only place they intersect. So this will be my answer. So I'm ready to conclude that there's an infinite number of solutions to this problem over here, and the solutions would be from 10 thirds up to, but not including, 11 thirds. Now, I'm a doubting Thomas. I always say to myself, maybe I wasn't thinking clearly, and many times I'm not thinking clearly. I convince myself to think clearly. What I like to do is go for a visual, all right? So what I want to do is, I'll certainly look through the work I typed up for you, and you certainly have my solution over here. So what I did over here is I graphed it, and someone says, what did you graph over here? I graphed this. And I only graph, certainly were the positive numbers, by the way. And then I looked at it, and I focused in on where it was equal to 10. And I did see a band of numbers where it was equal to 10. The next thing I did was I graphed in 2 lines. This line over here is x equals 11 thirds. And this over here is going to be x equals 10 thirds. All right? Now, granted, I realize looking at a graph something being a little deceptive over here, but I want to point out this is the band that satisfies this. What happens at 11 thirds? It actually just does jump up, by the way. All right? So I thought it was an interesting question. These things pop up on the internet, by the way, and I want to just go through this a little bit with you, and certainly, hopefully, you're paying attention to this. But at one time, it was believed that the internet would be a democratizing force in delivering education to the masses, and it would revolutionize it. In other words, it would give an opportunity to students everywhere if they had access to the internet. And pretty much, internet's universally accessible now, at least in the United States, by the way. However, what's happened is I think it's actually created a bigger divide between those enlightened. When I say those enlightened, those people that are spending a lot of time, watching high quality educational materials, and I do emphasize MIT because I was one of the early players in getting people to learn from great institutions, and MIT is one of those. And then I always say the adult-minded, people spend more time watching, I say stupid cat videos. All right, now people do that. Be aware of this though, that what's happened though is that the go-getters are now being overwhelmed with choice on the internet. Like if you go to YouTube, you'll see, the number of videos being posted per day on YouTube of high quality mathematics is quite good. I would recommend that you take advantage of those resources. All right? Take advantage of them. That you'll be able to go to YouTube and be able to see problems that you would just not see in a classroom at Essex. And you want to do that. You want to see what's going on here. Here's the problem though. the skill set starts to improve over time because so many people are watching those videos. And they need more and more entertaining videos. When I mean entertaining, a lot of people are entertained by things like this over here. All right. Now, granted, I do reference over here that, you know, you could look at this thing and say to yourself, I wonder if you could write another problem where this would be more difficult to deal with. And you could. I mean, you could keep writing problems over and over again about this one over here. But the deal about this over here is become familiar with the richness of what's going on in the internet now. And there is a lot of stuff going on. Take advantage of it. And YouTube is a great place to start. Thank you.